the atomic physics chapter. It's the time for problem, and remember this chapter is mainly concerned about the problem in board exam. Okay, so first question for today: what is the order of velocity in a hydrogen atom in ground state? Again, what is the order of velocity in hydrogen atom in ground state? Order, it is asking order. There are 4 options, so we have to solve it. Okay, so here the answer. For hydrogen atom, velocity V is equal to 1 by 137 into C by N. I have already said you to remember this formula. Okay. Here asking about ground state orbit. Ground state orbit n is equal to 1. Here c is the velocity of light. C is equal to 3 into 10 to the power 8 meter per second. Then velocity v is equal to use this value 1 by 137 into 3 into 10 to the power 8 divided by 1. It is 300 into 10 to the power 6 by 1 by 137. This is meter per second. So this become 2 point something. It is 2 point something into 10 to the power 6 meter per second. Okay, so asking about order. It's asking about order. So we only consider this value, that is 10 to the power 6. So answer is option B. It is 10 to the power 6. Please note down. So next question. Here the second question. See over here, the ratio of radii means radius corresponding to first and second excited state of hydrogen atom. It is saying about excited state of hydrogen atom. Okay, so I am drawing the diagram over here. This is our nucleus. This is our nucleus. So this is our first orbit, that is n is equal to 1. This is 2 and this is 3. So this is our ground state orbit. Okay, remember this is our ground state orbit. Then first excited state orbit is 2. Second excited state orbit is 3. Okay, so here given first and second excited state orbit. Okay, so here is the answer. We know, what we know? Radius of hydrogen atom. Radius of hydrogen atom R is equal to 0.53 Armstrong into n square. 0.53 into n square. Okay. For first excited state orbit, n is equal to 1. Sorry, n is equal to 2. Okay. Then radius, let's take R1 is equal to 0.53 Armstrong into 2 square that equal to 4 into 0.53 Armstrong. Similarly, for second excited state orbit R2 is equal to 0.53 Armstrong into 3 square, because here n is equal to 3. So this becomes 9 into 0.53 Armstrong. And the question is asking about ratio first to second. Ratio first to second means R1 by R2. Then ratio R1 by R2 is equal to 0.53 Armstrong into 4, 0.53 Armstrong into 9. Then the ratio becomes 4:9. Here the fourth option, answer is 4:9. Okay, check out. Here is the third question. Look at over here. In a hydrogen atom, an electron jumps from third excited orbit to first excited orbit in Balmer series. Find energy and wavelength of radiation. Energy and wavelength of radiation. This question is very easy question and very much important for board exam point of view. Okay, let's do the answer. Here given Balmer series. For Balmer series, first excited orbit N2 is equal to first excited orbit. Let's take N1. N1 is equal to 3. Third excited orbit N2. Let's take N2. N2 is third excited orbit is, if first excited orbit is 3, then second, 4, third, 5th. Third excited orbit belongs to 5th orbit, 5. So it is asking about energy and wavelength. We know the equation of wavelength. Wavelength 1 by lambda, jumping from electron third excited orbit to first excited orbit. So this is 1 by lambda 5 to 3. This become R into 1 by n1 square minus 1 by n2 square. This equal to 1.093 into 10 to the power 7. Sorry, take R and at last we will put the value of R. 1 by 3 square minus 1 by 5 square. Okay, so this become R into 3, 9, 5, 25. So 9 and 25, LCM become 225. Okay, this become 25 and this become 9. So this equal to 16 R by 2 to 5. So lambda 325 is equal to 225 by 16 r. Here r is 1.093 into 10 to the power 7 meter inverse. Okay, by putting this value over here, you will get the answer. Okay, or if you are doing this much for your exam, then it will also okay. Okay, now it's time for energy. Energy radiated when electron jump from third excited orbit to first excited orbit. Okay, energy. First, let's take for first excited orbit. E3 is equal to what we know the formula. E3 we know energy. Okay, energy E is equal to minus 13.6 electron volt by n square. Okay, for E3 it is 13.6 electron volt divided by 3 square. This become 13.6 eV divided by 9 is equal to minus 1.51 electron volt. This is E3. Similarly, E5 for third excited orbit. E5 minus 13.6 eV by 5 square. This become minus 13.6 eV by 25. Then E5 is equal to 13.6 divided by 25. Six, 10, 20, 3, 6, 11, 0.52 electron volt. Okay, clear? Then the energy radiated. Energy radiated means what? The energy difference between third orbit to fifth orbit. Clear? So energy releases. I have no place to do, so I am erasing this wavelength part. Energy releases E is equal to E5 minus E3. This equal to minus, this is minus 0.52 electron volt minus of minus 1.51 electron volt. Okay, this become 0.99 electron volt. Okay, this is the energy. If you want to make it in joule, you can put 1 electron volt is equal to 1.6 10 to the minus 19 joule. If you put this value over here, you will get the answer. Okay, so this is a bit lengthy question, so just copy it. So here is the fourth question. The ground state energy of hydrogen atom is minus 13.6 eV. If an electron jumps from an energy level this much to this much, 0.85 eV to 1.51 eV, calculate the wavelength of the spectral line emitted. To which series of hydrogen atom this wavelength belong? Okay, remember student, given the ground state energy minus 13.6, if you know which orbit belongs to this energy, you can easily define which spectral series this wavelength belong. This is the first question answer. Then after, what is the wavelength? We just need to know which two orbit belongs to this energy. If you know this, then we can easily calculate all our answer. So let's see the answer. Given energy of ground state orbit, energy of ground state orbit, that is minus 13.6 eV. What we know the equation of energy? Energy E is equal to minus 13.6 eV by n square. So comparing these two, we can get the value of n. This means minus 13.6 eV by n square is equal to 13.6 eV. This value cancel out. Here n square is equal to 1. That means n is equal to 1. So n is equal to 1 is the ground state orbit. Then which series it belongs? It belongs to Lyman series, obviously. Hence the spectrum series is Lyman series. Okay. After getting these two orbit number, we can easily define the wavelength. Okay. So just put the same equation for these two values. Okay. For energy E is equal to minus 0.85 eV, this equal to 13.6 eV by n square is equal to 0.85 eV. Here n square minus cancel, 0.85 divided 13.6 divided by 0.85. So this is 4. This is 13.6 eV by 0.85 eV is equal to 16. Okay. So this become n is equal to root over 16 is equal to 4. That means this energy belongs to fourth orbit. Okay. Clear? Next, for this energy, here I am writing this belong to Lyman series. For energy E is equal to minus 1.51 eV. E is equal to minus, this equal to minus 13.6 electron volt by n square is equal to minus 1.51 eV. This equal to n square is equal to 13.6 by 1.51, this equal to 9. So n is equal to 3. Okay, this means this transition is take place from fourth orbit to third orbit. Okay, then we need to calculate the wavelength. Okay, I am erasing this part. Wavelength 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Here transition takes place from 4th to 3. So this is our n1 and this is our n2. So this equal to r into 1 by 3 square minus 1 by 4 square. Okay. So this is r 9, 16. This is 144, 9, 16. 16 minus 9. So here 1 by lambda is equal to 7r by 144 lambda. Here lambda is equal to 144 by 7r. Okay, put the value of r. Remember, r is equal to 1.093 into 10 to the power minus, sorry, not minus, this is plus 7 meter inverse. So put this value over here, you will get your answer. Okay, and remember, this wavelength belongs to which series? This wavelength belongs to Lyman series. Okay, so fifth question for today. This is my last question. I will do next 5 questions tomorrow. Okay, here given, determine the radius of the first orbit of hydrogen atom. Radius of first orbit of hydrogen atom. What should be the velocity and frequency of the electron in this orbit? Okay, very simple question. You just need to remember few formulas. Answer: for first orbit of hydrogen atom, pratham orbit, but first orbit, n is equal to 1. N is equal to 1. Then it is asking about radius. So we have the formula. Radius r is equal to 0.53 Armstrong into n square. Okay, put n is equal to 1. You will get the answer. 0.53 Armstrong into 1 square is equal to 0.53 Armstrong. This is our answer. Okay, next it is asking about velocity. V is equal to, I have already said, 1 by 137 into c by n. Put n is equal to 1. We know speed of light 3 into 10 to the 8 meter per second. So 1 by 137, 3 into 10 to the power 8 meter per second divided by 1. So this become 2. This is 300 by 137 into 2, 4, 7, 2, 6, 26 to 60. 2.1 into 10 to the power 6 meter per second. Okay, so this is our velocity answer. And it's asking about frequency of the electron. So what we know the formula E is equal to h nu. H stands for Planck's constant and nu stands for frequency and E stands for energy. If we know the energy of first orbit, then we can easily calculate its frequency. Let's do it. Energy E1 is equal to 13.6 eV. Energy E by n square. Here is the negative sign. Clear? For n is equal to 1, E1 is equal to minus 13.6 eV. But what we know? E is equal to h nu. Nu is the frequency. This become h nu is equal to minus 13.6 eV. I am not taking the negative sign because I am only calculating the magnitude. Here h, given h, Planck's constant. So nu is equal to 13.6 eV, electron volt. I have said electron volt is equal to 1.6 10 to the minus 19 coulomb. So 19 joule. 1.6 into 10 to the minus 19 joule divided by h. Divided by h. I am doing my answer over here. I am erasing this. This equal to nu is equal to 13.6 into 1.6 by h. This is 13.6 into 1.6 into 10 to the minus 19 divided by here is h 6.6 10 to the minus 34. Okay, you can do this, you can answer it. Okay, here 1934, what is the answer? 15, 10 to the power 15. I'm using the unit hertz. 13.6 by 6.6, 6.6 into 2 13.2, 2.4 by 6.6. Let's take it 2. Okay, into 1.6 into the 15, this become 3.2 into 10 to the 15 hertz. This is our new. This answer will slightly vary and it will manageable. Okay, I have not taken the fractional value. Clear? So you can take this answer. This is my frequency answer. Okay, for today this much only. Next class I will do some more problem, so please join my class and subscribe it, so it will make me to do more class. Okay, thank you.